All right, good day. Hope that you're doing well. So in this video, we're going to be doing your trig exam questions from your 2023 November paper 2 question paper. All right. So now we're going to start off with question 5. Now, question 5, they're telling us that if 3 sine b is equals to 2, right? If 3 sine b is equals to 2, right? And cos b is less than 0. Now, this is important. And you will see what do I mean by that. Determine with the aid of your diagram and without the use of your calculator, meaning that you should try to use, you should try not to use a calculator, but you can, right? But then now let's try and answer this question with the aid of your diagram. Now, the first step is going to be drawing your diagram. So now, first, I'm going to use this 3 sine b is equals to 2 that I'm given. I'm going to make it to be in terms of sine b, right? And to get rid of this 3 because it's multiplying, I'll just divide both sides by 3. And now doing so, my sine of b is going to be equals to 2 over 3. Now remember your SOHCAHTOA. Sine is opposite over hypotenuse. Now, we should try to draw our sketch, right? Now, they're telling us that cos of b would always be a negative value. Now, what can we interpret by that? So if they're saying our cos of b, it's always a negative. Now, remember, cos is adjacent over hypotenuse, right? This is our cos. And I want you to note something. Your hypotenuse, it's always positive. Right? It can never be a negative value, meaning that the only thing that would make this cos to be a negative in accordance to the restriction we are given here, it is if this adjacent value, it is a negative value, right? Meaning that this adjacent is a negative. Now, if I were to draw my Cartesian plane here, right, where I would be drawing my diagram, right? Now, remember on your right angle triangle, right, if I were to make a rough sketch here, this is your hypotenuse, the line that is opposite to 90 degrees. This is your opposite, if this is your reference angle, and this would be your adjacent. Now, this adjacent here, we're seeing that it's going to be a negative value, meaning that our sketch is going to be this side, right? Because why in this quadrant, our x values are negative, right? So always, when they're telling you that your cos b should be less than 0, it simply means that your adjacent value or your x value on your right angle triangle, it should be a negative value. Now, trying to draw my right angle triangle here, right? So I'm just going to try and draw it here. All right. And in accordance to the ratio that I already have, I know that sine of b, if this is my reference angle b, sine, right, this would be my opposite. If 90, this would be my hypotenuse, this would be my adjacent. Right? Now, and I'm saying that, all right, the sine of my b is going to be opposite, which is 2, over my hypotenuse, which is 3. Now, let me try and solve for my adjacent. Now, how would I solve for my adjacent? This is a right angle triangle. I can use my theorem of Pythagoras. R squared is equals to x squared plus y squared. Right. So what is it that I'm trying to determine? I'm trying to determine my x, so I could make this formula to be in terms of x by simply taking the y to the other side. So basically x squared is going to be equals to r squared minus y squared. Now x squared is going to be equals to my r, which is 3 squared, minus my y, which is 2 squared. Now square root both sides to get rid of the squared. As a result, my x is going to be equals to the square root of 9 minus 4, right? And as a result, my x will be square root of 5. Now remember, because of our restriction, we said in order for cos b to be a negative, the only thing that will make this cos to be a negative is this adjacent, if it's a negative value, because your hypotenuse can never be a negative, meaning that here, this would be minus root 5. So hence I say every time whenever they tell you that your cos b should be less than 0, it means that your adjacent value, right, should always be a negative value in that instance, right? So now making use of this diagram, we're going to try and solve for the questions that we are given. So let me try and erase here first. Now the first question, it says 3 cos squared b minus 1. Now this is the same as 3 multiplied to the cos of b all squared minus 1, right? So I'm going to say 3 multiplied by my cos. I'm going to get it from this diagram. Remember, cos is adjacent over hypotenuse. Now, in this instance, what is my adjacent? My adjacent is negative square root of 5. My hypotenuse is 3 minus 1. So now, solving for this is going to be 3 multiplied by, so this squared, right? So if you have something like this, 2 over 3 squared, this is the same as 2 squared over 3 squared. Now, as a result, this is going to be 3 multiplied by, so here, negative square root of 5 squared all over 3 squared minus 1. Now remember, anything squared is a positive. For example, if I ask you to find negative 3 squared, your answer would always be a positive value. So anything that you square, it's always going to result in a positive value, whether it's a negative or a positive number, right? So in this instance, as a result, first this negative is, we're going to get rid of it, and also the square root here is going to be cancelled by the squared. So basically you'll be left with 3 multiplied by 5 at the top all over 9 minus 1. So now here I can multiply numerator by numerator, denominator by denominator. This is the same as divided by 1. So this would be 15 over 9 minus 1. So their common denominator is 3, right? So their common factor is 3. 3 goes 3 times into 9, and it goes 5 times into 15. So this would be 5 divided by 3 minus 1. And simplifying this further, remember, I'm going to try and make them to have a common denominator, LCD, right? So basically my lowest common denominator in this instance is going to be equals to 3. So how can I make this other value to have 3 as a denominator? This is if I multiply it by 3 over 3. So as a result, if I do so, this would be 5 over 3 minus 3 over 3, right? So in this instance, my final answer can be 5 minus 3 is going to be 2. I can retain my denominator, which is 3. And this would be my final answer. Now for the second question, we have a negative b, the tan negative b minus 180. Every time whenever you have a angle like that, try to make it, or try to take it negative 1 as a common factor, right? Every time whenever you have something like that. So here I have tan, let me just write it here, minus b minus 180. Now inside my brackets, I'm going to take out negative 1 as a common factor. So as a result, this would be tan. If I take out negative 1, here I would be left with b. Here I would be left with positive 180. Because when I multiply this negative back into my brackets, I should get the same values here, right? Now, as a result, note that now you have a negative angle, which is here, right? So remember, with regards to negative angles, let me write down these. You have sine, you have cos, you have tan. Now, sine, it is affected by your negative angle. So as a result, this is going to be the same as minus sine theta. Now, your tan, it is affected by a negative angle. As a result, this is going to be minus tan theta. But your cos is the only identity that is not affected by a negative angle. So this is going to be positive cos theta. Right. Now, as you could see here, you have a negative angle and you have tan, meaning that this is going to be affected, right? So as a result, this is going to be minus tan. So minus, remember this minus here, it's multiplying to this tan. And inside your bracket, you have 180 plus b, or you could write it as b plus 180, either way, right? So I want you to note something. So let me just, so this minus is multiplied to that, right? So now let us focus into this bracket here, which is multiplied to your negative. Now, 180 plus b, we would need to make use of our cast diagram to find if in the quadrant of 180 plus, it's tan positive or negative, right? So let me just quickly draw my cast diagram here on the side. So if I were to draw it here, so here it's 90 minus x. Here it's 180 minus x. And I like to also write it as 90 plus x. But most of the time, I'm going to make use of that. So here it's 180 plus x. And this is 360 minus x. In this case, our reference angle is b, right? So now 180 plus b, it's in the tan quadrant, right? As you could see, this tan need to be a positive. So here we would have negative multiplied to positive tan b, right? Now, let me substitute my tan b using my diagram. So I have minus multiplied to my tan. Remember, tan in accordance to SOHCAHTOA, it's opposite over adjacent. Now my opposite, it's 2 divided by my adjacent, which is minus square root 5. Now, because of this negative here, and my denominator is going to make the whole fraction to be negative. So as a result, this would be minus 2 square root 5. And these two are going to cancel out. And your final answer would be positive 2 square root 5. All right. And that will be all for 5.1. Now remember, with 5.1, you first need to draw your diagram, your right angle triangle, taking into consideration any restriction that you might be given. All right. Now, also, it's important for you to know that these kind of questions, especially on 5.1.2, you would always get them. Now, what do you do in those kind of scenarios? You take out negative as a common factor, just like we did here. And from there, you're going to make use of your cast diagram. And after, you use your sketch again to solve for your identity. All right. So now let us move on to the next question. Now, for the next question, they say t cos of 15, this is equals to 4. Now we need to solve without the use of a calculator, and our answer should be in terms of t. Now, every time whenever you have these kind of questions, you're going to draw your right angle triangle, the sketch that you're going to use to answer those identities you are given there. So I'm going to try and draw my right angle triangle here, and I would need to determine values that would be in this right angle triangle. First, I know that my angle here is 15, so meaning that my reference angle is going to be 15 degrees, right? And this side would be my opposite, this side would be my adjacent, here it would be my hypotenuse. So now let me make this to be in terms of cos 15. And how would I do that? I would divide both sides by t in order to get rid of t this side. So as a result, cos of 15. So here 15, it's the same as B in this instance. It's your reference angle. You're not going to use this 15 to solve for anything. Basically, you're not going to punch this into your calculator, right? So you need to make use of your sketch here, and you need to show that sketch on your answer sheet. So cos of 15 in this instance is equals to 4 divided by t. Now remember, what is cos? Cos is adjacent divided by your hypotenuse. So here, if I were to substitute my values, my adjacent would be 4, my hypotenuse would be t. Now let me solve for my y using theorem of Pythagoras. So r squared is equals to x squared plus y squared. Now I'm looking for my y. I'm going to make this equation to be in terms of y by simply taking x to the other side. So as a result, y squared would be equals to r squared minus x squared. Now substituting values, my y squared is going to be equals to my r, which is t squared, minus 4 squared. So as a result, I need to get rid of this squared. I'm going to square root both sides. So my y, it will be equals to the square root of t squared minus 4 squared, which is 16. So this would be my y value. Minus 16, right? So now let me just erase here. Now that we have our diagram, we can try to answer these questions that we are given. Now, let me see what the question is requiring us to calculate. So now here, they want us to find sine of 15. Now remember, sine, it's opposite over hypotenuse. Now my opposite in this instance, so I'm going to write here, sine of 15 is going to be my opposite in this instance, which is t squared minus 16 divided by my hypotenuse, which is t. And this would be my final answer. Now, sine of 75. Now, we're going to try and reduce the 75 to be 15, right? Making use of our cast diagram. Now, when you add 15 and 17, right, they add up to 90, right? So as a result, it means that here I can just simply represent this as sine 90 minus 15. All right. Now, 90 minus is in which quadrant? This quadrant. And here, all values are positive. Now, always whenever you have sine of 90, whether it's 90 plus or minus, it's always going to change to cos. Same applies with your cos. Always whenever you have cos of 90, whether it's 90 plus or minus, it's always going to change to sine. So as a result, this here is going to change to cos, positive cos 15, right? And now, because it's going to change to positive cos 15, we're going to make use of our diagram here. Cos, it's adjacent over hypotenuse. So it's going to be your 4 divided by your t, right? Cos 15 is 4 divided by t. Now, what about 1 minus? Now, also, I want to explain the other concept with regards to your causes changing to sines as well as sines changing to cos. Now, let's say you have cos 90 plus x. First, you ask yourself, 90 plus x is in which quadrant? This is in the sine quadrant. Now, is cos positive in that quadrant? Nope. So I'm going to start by putting my minus here. And as a result, because this is cos 90, right, this would need to change to sine. So this would be minus sine x. So you ask yourself that 90 plus x, it's whatever the identity you are given here, is it positive or negative in that quadrant? If it's positive, you start by putting a plus. If it's a negative, you put a minus here. Then you change your identity. Now let us look into another example. Sine 90 minus x. 90 minus x, which quadrant is that? This is the quadrant where everything is positive. So I'm going to start by putting my positive. And this will change to cos of x. What about sine 90 plus x? 90 plus x is in which quadrant? It's in the sine quadrant. Now, is sine positive in that quadrant? Yes, sine is positive in that quadrant. So I'm going to start by putting my plus, and then this will change to cos x, right? Hopefully you get the technique, right? So now let us proceed with the questions that we given. Let me just try and erase here. Now for the next question, 1, minus tan. So this I can write it as tan 15 squared. Give your answer as a single fraction. We would need to simplify. So this would be 1 minus. Now let me look at my tan, right, which I'm going to substitute into my brackets. And remember, I have squared. My tan, remember, it's opposite over adjacent. Right? So this is my opposite. This is my adjacent. So it will be t squared, right? Square root of 2 squared minus 16 all over my 4. And as a result, remember before I told you that if you have a fraction that has a square root, that square root would multiply with your numerator as well as your denominator, right? So I made this kind of an example. If you have 2 over 3 squared, this is the same as 2 squared all over 3 squared. Now, applying the same principle here, 1 minus, so this would be square root of t squared minus 16 all squared divided by 14, 4 squared, right? So this is 4 squared. So this here would be 1 minus this squared is going to get rid of this square root. So as a result, I would be left with t squared minus 16 all over 4 squared, which is equals to 16. Now, if, remember, I have to, my answer should be in a single fraction, right? So I'm going to try and simplify this further, and I'm going to try to make these two denominators, so this is the same as over 1, to be the same. Now, my lowest common denominator in this instance has to be 16. Right? Or it is 16. So now how can I make this 1 over 1 be equals to, or my denominator here, how can I make it 16? So I'm going to take 1 over 1 multiplied by 16 over 16, which is the same thing as 1. Minus, this is already 16, so there is no need for you to do any workings there. You can just write it as it is. So this would be t squared minus 16 all over 16. So these are the workings you need to show, especially when they say your answer must be in a single fraction, right? So now here, this would be the same as 16 over 16 minus t squared minus 16 over 16. From here, I can retain my denominator. So here, I can retain my denominator, right, which is 16. And at the top, 16 minus t squared minus 16. Now, simplifying this, I'm going to distribute this negative inside my bracket. So as a result, this would be 16 minus t squared plus 16 all over 16. And these two are like terms, 16 and 60. And if I add them, they're going to be equals to 32 minus t squared, which is left all over 16. And this would be my final answer. Now, starting off with 5.3, we have cos 90 minus a, right? So let's first change that. We know that if we have cos 90 of something, this needs to change to sine. But first, 90 minus a is in which quadrant? All is positive here, right? So it means that cos 90 minus a is going to change to positive sine a. So this is going to change to positive sine a, all divided by, so here, the other sign that you have, so I'm going to try and do its workings on the side. So every time whenever you have a sign and its angle, it's a value which is greater than 360, in this case we have 540, right? So this is minus a minus 540. So whenever this angle is greater than 360, basically find the difference between this and 360, right? And if you do so, it will be 180, right? And you can rewrite this as sine minus a minus, so here it's 360 minus 180, because minus 360 and minus 180, they're going to add up to minus 540, right? So you can rewrite it as that. And because sine is an identity with a period of 360, remember the period of sine is 360, your cos is 360, and your tan is 180. Now, because sine, it has a period of 360, you can write this as sine. You can exclude the whole 360. You can write this as sine minus, right, a minus 180, right? Now, afterwards, what you're going to do in this instance, you're going to say, all right, so now you can take out a negative as a common factor inside your bracket, right? So basically, this is going to be sine. If I take out a negative as a common factor inside of my brackets, I would be left with positive 180 plus a, right? So now this negative is going to affect my sine identity, right? So as a result, this minus, it will be multiplied to my sine, and here I would be left with sine 180 plus a. Now 180 plus a is in which quadrant? It's in the tan quadrant. Can you see? Meaning that this sign here is going to be negative. So this here is the same as minus sine a. So as a result, these two are going to cancel out, and finally, you're going to be left with positive sine A. Now, remember to show these workings on your answer sheet, right? You can try and do these on the side, and then you can substitute that here. So this here is going to be positive sine A. Remember, if you have a value or an angle greater than 360, try to find the difference between that angle and 360 and rewrite it as that. From there, because sine, right, it has a period of 360, this here is going to get cancelled out, and we're going to be left with minus A minus 180. Now, as a result, here we can just take out a common factor, which is negative 1, and do the steps that we are familiar with up until we arrive to positive sine A. Now, what about on my denominator? I have tan 225. Now, can I reduce this to a special angle? Yes, right? Now, basically this, I can write it as tan 180 plus 45. Remember, 45 is a special angles. Our special angles are 30, 45, 60, as well as 90, right? Now, this is added to, let me change the color of my marker. This is added to sine A multiplied to sine 180 plus A. Now, 180 plus is in which quadrant? 180 plus is in the tan quadrant. So that's going to be minus sine A. All right, now let's try and simplify this further. All right, so I'm going to first draw my line here. Right, so at the top here, I still have, so these sine A, they're going to multiply to sine A squared, or you can write sine squared A. Now 180 plus, so here I have 180 plus 45, right? So 180 plus is in the tan quadrant. So it means that tan is going to be positive. So that's going to be the same as tan, positive tan 45. And punching this into your calculator, your tan 45 should be equals to 1. All right, so this here is going to be 1. Now, these two, they're going to multiply to one another, right? And as a result, when I multiply them, it's positive sine A and minus sine A. They're going to be minus sine A squared, right? Now, let me give you a tip. Every time whenever you have minus 1 minus something, for example, 1 minus cos theta, or 1 minus uh, cos squared theta, any identity basically between cos and sine, or 1 minus sine squared theta. Here you would use this identity whereby you would say cos plus sine, it is equals to 1, right? Depending on what you are given. So if you are given that, you're going to make use of this, right? Now, because this is in terms of squared, so this can be the same as cos squared theta plus sine squared theta. This is equals to 1. Right? Same applies here because this is in terms of squared theta. You can use the identity cos squared theta plus sine squared theta. This is equals to 1. So whenever you have 1 minus sine of anything as well as 1 minus cos of anything, you would need to make use of this identity. And remember, it would depend on what you have. Hence here we have squared. It means that we're going to make use of this identity here, which is in terms of squared, right? So this, right, 1 minus sine squared A, right? This is the same as, so if I were to write this, this is the same as cos, right? So my cos squared theta, or my cos theta squared, it is equals to 1. Taking the sign to the other side is going to be minus sine, right? So this is the same as that cos squared theta, or cos theta squared. So if I were to rewrite that, remember at the top I have sine A squared. Now at the bottom I'm saying that this is the same as cos A squared, right? If you were to make it in terms of A. Now remember, your identity sine over cos is the same as your tan, right? In this instance, because we have squared, this would be tan A squared, and this would be your final answer for 5.3. Now let us move on to the next question. Now the first question for 5.4, which is 5.4.1, right? So basically, given 1 minus cos theta, it is equals to 2 sine squared theta. Show that the equation can be written in this form, right? This form that we are given right over here. Now, how would we go about doing that? Now, the first step here, I'm going to try to make everything here to be in terms of cos, because you could see that here everything's in terms of cos, right? Remember, sine squared theta, I'm going to use this identity. If I have cos squared theta plus sine squared theta, this is equals to 1. So sine squared theta basically is equals to 1 minus cos squared theta. So this would be my first step, trying to make everything to be in terms of cos. Right? The other side of it, 1 minus cos theta, this is equals to 2. Now this is multiplied to 1 minus cos squared theta. All right. Now, here, what will be the next step? The next step here, it will be to simplify, right? So basically, I'm going to start by distributing the 2 into my brackets, right? So now let me distribute the 2 in my bracket. So here I still have 1 minus cos theta. The other side, this would be 2 minus 2 cos squared theta. Now, afterwards, I'm going to equate everything to 0. So I'm going to join these to be on one side, right? So I'm going to make these to be on one side and equate everything to 0, right? So basically, I'm going to transfer these to the other side. Now, as a result, this here, it will be 2 positive 2 cos squared theta minus cos theta, right? Here, I would have 1 minus, this would be 2. And simplifying, this is 2 cos squared theta minus cos theta minus 1. And everything is equals to 0. From there, you need to factorize, right? So when you factorize this, so you exclude the cos, right? So basically, this is a quadratic equation in a sense, because here you have a squared, here you don't have a squared, but then you have a theta, and this here is 1, right? So basically here, it's the same as 2, right? So remember, your quadratic equation is ax squared plus bx plus c. Now, this is the same as our a is 2, our b is minus 1, which would be minus x, and our c is minus 1. This is like that. Now, try to simplify or try to factorize this and try to make it to be equals to that. Right? Basically, when we factorize this, we should get that. Right? Remember, in this instance, cos theta, it would act as our x, right? So here, our cos theta, it would act as our x values. Right? Now, how would you go about doing that? Now, taking this into consideration, now how do we do this? So first, you're going to multiply your a and c, right? So my 2 and my negative 1, when I multiply them, they're going to give me negative 2. Now, I'm going to look for factors that when you factors of negative 2, that when you add them, they're going to be equal to my value of b. In this instance, they're going to be equal to negative 1, right? Now, what are those factors? Now, what are these factors, right? So this is going to be minus 2 and positive 1. When I multiply these two, they're going to be me negative 2. When I add these two, they're going to give me negative 1. And I'm going to substitute them here. So basically, remember, I said my x squared or my x is the same as my cos theta. So this would be the same as 2 x squared minus 2x plus x. And remember, I have minus 1, right? Now, these minus 2, it is the one that is here, and this one, it is the invisible one that is here. Now, when you add these values, they're going to be still be equals to negative 1. From there, you can apply your grouping method, right? So you're going to factorize these. So you're going to factorize these individually as well as those individually, right? So doing so, taking out 2 as a common factor here, so taking out 2x as a common factor here, what would be left inside my bracket? It will be, so here it will be x, and there it will be minus 1, right? So here it will be minus 1. And on the other side, I could just write it as it is, minus 1. Now, both of them, right, both these terms have negative x minus 1 as a common factor. So if I take out x minus 1 as a common factor, what would be left? This side, I would be left with 2x. And this here is the same as the one that was multiplying here. I would be left with 1. All right. Now, this, can you see that is the same as that? Because we said let x be equals to cos theta. So this you can rewrite it as 2 cos theta for this bracket plus 1 is equals to cos theta minus 1, right? Which is what you were trying to prove. Now, every time whenever you're factorizing an identity equation, right? So try to make your identity to be in terms of x, or try to treat it the same way as x. Now, here, let's say you don't know how to do this, right? After this step, whereby you have made this a quadratic identity, you can just move on to writing this final answer, right? So there's basically no need for you to show these steps if you don't know how to do them. After you have made this a quadratic identity like that, basically here, remember the steps that we did, we made this to be in terms of cos because of the equation we are given. And after we equated everything to 0 and we group like terms. After this step, you could just write your final answer as that. You could just say 2 cos theta plus 1, here it's cos theta minus 1. Now, the reason why I showed you those steps is that in some instances, you would need to know how to go about doing this, right? So basically, it's for the purpose of understanding. But if you don't know how to do this for these type of questions, after you have written your quadratic trig identity like that, you can just move into your final answer as that. Now, hence determine the general solution of, so we need to determine the general solution of that. So remember, how would we go about doing that? So this is the same as 2 cos theta plus 1, it is equals to 0, which is the first bracket, or cos theta minus 1 is equals to 0. Now let me first solve for this. Let me first find theta in this instance. So to solve for theta here, I'm going to first start by taking the 1 onto the other side. So my cos theta, it will be equals to positive 1. Now I'm going to take the cos theta to be equals to the inverse of cos 1. Now as a result, my theta is going to be equals to 0 in this instance, right? And I will just write my period. My period for my cos graph is 360, and k are all values which are real numbers. So now here my first answer is 0. Now let me try and do for the other one. So this is 2 cos theta. I'm going to take the 1 to the other side, so it's going to become a negative 1. Now I'm going to divide both sides by 2, right, to get rid of this 2. So as a result, my cos theta is going to be equals to negative a half. Now taking cos to the other side to find theta, which is my reference angle, this is going to be the inverse of cos 1 over 2. And if I punch this into my calculator, my reference angle would be equals to 60. This is my reference angle. Now 60, let me look at to my cast diagram. So 60, so first thing first, I'm looking for cos, right? Cos is 360 minus, right? So I'm going to say 360 minus my reference angle, which is 60, and I'm going to get an angle which is in the cos quadrant. And in this instance, my angle would be at 240. All right, and now that 240 to be, now I'm going to write my period k 360, and k, it's all values of which are real numbers, right? All values which are real numbers. Now my reference angle, it is 60, and I found my k to be equals to 240, and that'll be all for this question, right? And remember, if ever you have any questions, always feel free to reach out. Thanks.